In this video, we're going to do some practice for adding and subtracting rational expressions with monomial denominators. This is section 5.10 practice from Al Grosch's book, Developmental Math 2. All right, looks like in the first question here, we're going to start with x over 3 plus y over 3. They already have the same denominator. So if you remember, we can't add or subtract any kind of rationals or fractions unless they have the same denominator. Since these two already have the same denominator, we're good. The denominator is going to be 3, and we're just adding the numerator. So x plus y. This is subtract, and again, we have to have the same denominator. We already do, so the denominator here is going to be the same, and we will just subtract the numerator, so 3x minus x. Now, this is where you have to be careful, because these two terms are like terms. So after you do the subtraction, or you lay out the subtraction, you have to combine like terms. So 3x minus x is 2x. So this will be 2x over 5y squared. All right, looking at the denominators here, they are already the same. So this denominator is going to be yz cubed, and we are going to add the numerators. So we'll have 2x squared plus 3x squared plus 7, and then checking for like terms. These are like terms, 2x squared plus 3x squared. These are like terms. When I put them together, I get 5x squared. So I have 5x squared plus 7, because we still have this plus 7 here, over yz cubed. All right, this is a subtract. The denominators are already the same. So I'm going to have a denominator of 6x. You have to be careful with the subtract, because if you have more than one term, that subtract has to distribute. So we'll end up with, in the numerator, 2x plus 1 from here, and then this is going to be negative 4x, and then this will be a positive 5. So negative 4x plus 5, and now we have to look for the like terms. So 2x and negative 4x are like terms, and that makes negative 2x. Positive 1 and positive 5 makes positive 6 over 6x. Now this is a tricky one, because we've got some reducing that can happen here. I'm not going to reduce these 6's like this or these x's like this because of this binomial here. However, this binomial has a GCF of 2. So we can factor out a 2 here, or a negative 2, and leave that with x minus 3. And then the 6x in the denominator can be factored also to be 2 times 3x. And these 2's can cancel now since they're factors. So we're left with negative x minus 3 over 3x. All right, now we're going to practice with different denominators. So if you watch the lesson, we know how to find a common denominator. The common denominator has to have all the factors of both of the original denominators. So we're going to have a 5, and we will also have to have a y. So that gives us a common denominator of 5y. So I'm writing two new fractions with a denominator of 5y, and my answer will have a denominator of 5y. So to get from 5 to 5y, we need to multiply times an extra y. So this denominator is going to get multiplied times y, and that will give us just a y. To get from y to 5y, we have to multiply times 5. So this numerator needs to be multiplied times 5, and that will give us a 20. And now we can just add these numerators. So we will have y plus 20. Here we have a subtract, and again, we're going to find a common denominator. The common denominator has to have an x and a y in it. And this denominator has a y, but we've already got the y covered, so there's some overlap here. So we can just use the denominator of xy. And our answer will also have a denominator of xy. So we're not changing this denominator at all, so we don't need to change the numerator either. This denominator, to go from y to xy, we need it to multiply times x. So the numerator will also get multiplied times x. Now we just have to subtract, and we have 2 minus 8x. Okay, we're going to find a common denominator for this question. We have to have all these factors in it, and I'm going to use some prime factors here. We know that 4 is 2 times 2, and we have 3x's. So we're going to start with that for our common denominator, 2, 2, and 3x's. In this second denominator, we have a 3, 2 x's, and a y. Well, we have no 3 yet in our common denominator, so I'm going to put a 3 here in front of the 2's. We need 2 x's. Well, we've actually got 3, so we have those 2 x's covered. We don't have this y, so we're going to put a y on here. And when we multiply all that together, we get 12 x cubed y, and that's our common denominator. So I'm going to write 2 new fractions with the denominator of 12 x cubed y and my answer. So now we got to think about, to go from 4x cubed to 12x cubed y, what do we have to multiply by? Well, to go from 4 to 12, we will have to multiply by 3. So I'm going to multiply this numerator by 3. And to go from x cubed, okay, these x cubes match, so I don't need any more x cubed, but there's no y here. So to get this extra y on, we'll have to also multiply by y. So this numerator needs to get multiplied by 3y, and that will make 9y. We're going to do the same thing over here. To get from 3x squared y to 12x cubed y, well, the 3 has to get multiplied by 4. So this numerator is going to get multiplied by 4. The x squared, well, now I have x cubed, so I'm going to need to multiply by an extra x. And the y's match. So this numerator needs to get multiplied by 4x. So 7 times 4x is 28x. And now I can add these numerators. I will have 9y plus 28x. All right, let's find a common denominator for these two. In this denominator, I'm going to need a 2 and a couple of x's. X squared gives me these 2 x's. Here I'm going to need a 5, which I don't have yet. So we're going to multiply times a 5. One of these x's I've already got, but I don't have any y's. So all that multiplies to make 10x squared y. So I'm going to multiply my 2 fractions to get 10x squared y. And my answer will have a denominator of 10x squared y. Okay, so to get from 2x squared to 10x squared y, 2 times 5, so I'm going to need a times 5. The x squareds match, so no x's, but there's no y up here. So to get this extra y down here, I'm going to have to also multiply times y. So y times 5y gives me 5y squared. To get from 5xy to 10x squared y, well, 5 times 2, so I'm going to need to multiply times 2. X to x squared is multiplying times another x. But it looks like the y's match. So the 6 needs to be multiplied times 2x, and that will give me 12x. So now I can just subtract these two denominators. So I'll have 5y squared minus 12x.